Hello, everybody. Welcome to the 6 Fly AI webinar. Today, we will focus on cybersecurity and how cybersecurity can be also supported by artificial intelligence, machine learning, but we will see that the other aspect of the coin, how AI can be used to conduct cyber attack and how some applications can be attacked to modify the behavior of those. So I'm Patrick Mana. I'm the cybersecurity program manager and EATM cert at EUROCONTROL. And today I will have the pleasure to be your moderator. So the objective today is to demystify how AI can be used, and you will see that we have a panel of organizations and concrete applications that will be shown today, so that we can not only, I would say, address the topic, but show you live. We'll have some demos, show you live how this is being done and how we are working on that. Understanding the benefits, the limitations, the lessons learned from those early applications. So what is important is that we are here to provide some information, but also you will see that quite often we'll engage with you, because somehow there is one important element, which is a call for sharing, for working together. So not only we will show what we have done, but we are all looking for working together on the topic. So before I introduce the panelists, I just want to do some housekeeping rules. So you see that you have a chat button and a Q&A. So the chat is only if you experience some problems, if you want to have some responses to technical questions, though the Q&A question answer are really for you to address the panelists. And I will pick some of those questions and then ask those questions to the panelists. So please don't be disappointed if some of your questions are not addressed. There will be probably many. We will address only some of those. Be aware that also we are recording the session. So for your colleagues who didn't have the opportunity to join us today, will have a second chance. And we are on YouTube and LinkedIn. So now I would like the panelists to introduce themselves. And I will start with Julien.
I'm Julien de Blander. I'm data scientist from Southwest area, working as a consultant for EUROCONTROL, the NM lab. And I'm mainly specialized in natural language processing projects.
Thank you. Then I will hand over to Adeline and Dalel so that they introduce themselves.
Hello, I'm Adeline Courdet. I'm the product manager for Insider Protection, which is an Airbus product. So I'm part of the cybersecurity department of Airbus, especially the department which is called Detection and Response. And we started this nice journey of leveraging machine learning for cybersecurity purpose 2 years back. And I will be happy to show you how it goes right now after 2 years together with my colleague.
Okay, thank you, Dalel.
Good afternoon. My name is Dalel Bouslimi. I'm working in Airbus also as a cybersecurity data scientist. My role consists in the designing and the development of new threat detection capabilities based on the artificial intelligence and user behavior analytics.
Thank you, Dalel. Patrick?
Hi, good morning, good afternoon, and good evening to all of you. I'm Patrick Redon from Thales. I'm a cybersecurity architect at Thales Cybersecurity Defense Solution Business Unit. And previously, I was the cybersecurity authority of our ATM business unit, leading its cybersecurity strategy. Thank you.
Thank you. Hannes?
A very good day from my side. Hannes Alperslan. I'm with the European Defense Agency and working on cybersecurity for the air domain, and also dealing with everything that is new, emerging, and disruptive technologies in aviation.
Thank you, Hannes. So you see that we have a quite range of panelists from different organizations, and we will start immediately with the first presentation, which is on this one I will play a double role, so not only moderating but also presenting. So Julien, you can start sharing. In fact, in the ATM CERT, which stands for the European Air Traffic Management Computer Emergency Response Team, we have started to think about the use of artificial intelligence, machine learning, Mostly because, amazingly, in cyber, sometimes we think that we have little data to share, but sometimes we have too much data. So next slide, please, Julia. And one of the issue we found is that we are having a contract with a company which is helping us to search for information which has leaked, documents which have leaked on the dark web, deep web, but also public internet or connected storage. And more importantly, this information is confidential or sensitive. And therefore, one of the tricks is to get access to those information and understand if this information is really aviation-related and sensitive. So typically, the company, we give them keywords, and they are searching, and they give us a kind of certain number of findings. So you can see that in 6 months, we found out nearly 3 million documents, but only 55,000 were kind of considered relevant by their artificial intelligence applications. And then out of that, we discovered that some kind of order of magnitude of 50 documents were actually aviation-related and sensitive. But going from the 55,000 to the 50, it's human having to look at that. So typically, one of the objectives, next slide, was to develop our own EATM cert application, trying to reduce the number of documents that we have to go through to detect whether they are aviation-related and sensitive. For that, one of the aspects that we faced was that the data, by definition, are sensitive, and they are connected, they're coming from various sources. So one of the issues we found is the security of the data. We need to have those data in a place that is secured, meaning that physically, there is already a first level of security. So Julien, for example, had to come to the agency to work, even though it was during the pandemic. He was not able to work at home from whatever cloud. We were not willing to put the data on the cloud. And the data were on our data server, which is not connected to EUROCONTROL data server, and not connected to, I would say, any other systems. One of the points also is that the data the good documents we are collecting, some of them are coming from a dark web, deep web, so they can be insecure. So the content of the document could be also not only sensitive, but also malicious. So that's one of the issues we found when developing that. So the objective that I gave to Julien is that give us an application that can help us to detect whether a document is aviation related and sensitive. So Julien, the floor is yours now.
Thank you, Patrick. So the first thing I would like to show you is what we did on this project and what we plan to do in the future. So for now, we have aggregated all the documents and we have also labeled them. This is marked as an iterative process because we are constantly looking for new documents to label to further improve our algorithm. We have been doing the pre-processing step where we basically extract the content from our documents. This will serve for our natural language processing application, where we want, as Patrick said, detect if a document is related to the aviation or not, and also detect its level of sensitivity. In the future, we would like to build a computer vision algorithm in order to detect the images we found in leaked documents or either in leaked folders. This makes up the cyber for AI part of our project. And on the other hand, we have AI for cyber as well, where we plan to build an adversarial machine learning model to actually test the robustness of the NLP algorithm and the computer vision algorithm. To build our document classification algorithm, we needed on one side positive data and on the other side negative ones. The positive document can be any type of document that is related to aviation stakeholders. So it can be reports, it can be NDAs, or even emails from aviation stakeholders. And on the other hand, you have non-aviation related subjects. In this case, we have mainly chosen reports for the European Commission. And then those texts will be fed into the algorithm. Talking of the pre-processing pipeline, we had actually to come up with a global solution that had to deal with many different kinds of extension, because in the folders, you may find Excel files, you may find Word, you may find videos, audio files, etc. So we come up with the solution you can see on the slide. On one side, we will actually extract the images from the documents and store them into separate folders to be used in our next algorithm that will be computer vision one. And on the other side, the text content will be further processed through some functions. The first one is to format the content of the text and then detect its language, and we'll then save it into a data set so as to be further processed by the ENLP algorithm. In order to convert the text into numbers in order to be understood by the model, we needed to come up with a global solution that was able to understand many different languages. So for that, we have been using a multilingual pre-trained language model called BERT, provided by Google as an open source project. We have chosen this solution because it allows you to reach a great accuracy with only a few annotated examples. However, you have to keep in mind that this solution needs a solid hardware configuration with a GPU with at least 10 gigabytes of memory. We found out that the best iteration of our model took roughly 3 hours to train with our GPU with 48 gigabytes of memory. So we have been working with a pre-trained language model in combination with a convolutional neural network. As you can see from the table on the left side, it's managed to slightly better classify aviation-related documents than non-aviation-related ones. And we also wanted to explain the outputs provided by the machine learning classifier. We did that with the LIME library. As you can see from the screen there, you can see that the word aerodrome and aeronautic are tagged in blue, which means that the algorithm is providing a high confidence score towards aviation related for this document. Here I would like to show you a small demo of what it looks like. Actually, here we are basically running a script where we will select the folder we would like to analyze. And then it will preprocess all the documents inside this folder and give you a confidence score for each of the documents found in the folder. In this case, you can see that we have 18 documents relevant out of the 34 that are in this folder. A second demo to show you what it looks like under the hood. So here, basically, you will be copy pasting the content from a document. This document is blurred because this is a sensitive one. So basically, you copy paste it into a box, and you will run the algorithm, and it will provide you with a score, either positive or negative. And this one is a positive document. So we have also an example with a negative one. You will, as before, copy paste its contents, and then it provides you with a negative score for this one. One of the challenges we had during this project is that pre-trained language models are not able to handle very large files. So it is recommended to use a paragraph with roughly 500 words. In our case, we could overcome this recommendation with our GPU because we have extra memory in our GPU. So we could extend this limit up to 6 pages. But so for the next step, next iteration, we would like to divide the long document into paragraphs and then label each of these paragraphs in order, firstly, to reduce the training time of the algorithm, and secondly, to reach a better accuracy because the algorithm will be able to more focus on a paragraph rather than on a very long text. However, it will be more time consuming because you have to label the paragraph individually. A second issue was that you may find documents that don't have any context. So for example, you may find on the dark web a list of websites that have been hacked, and one of these websites is a website that is related to the aviation. or you may find an email from an EUROCONTROL employee, but the topic of the email is not talking at all about aviation. And so in this case, we have to come up with keyword detection, which will improve our current solution. So in this case, you can see that we will be matching the EUROCONTROL in email or Brussels Airlines, Bulatsa, etc. To further improve these keywords detections, we wanted to come up with a name entity recognition system that will go beyond keywords detection. And in this case, we want to match, for example, airport names or airlines companies. So we did the first iteration of that. And we have, as before, used a multilingual language model with, in this case, a transition-based algorithm. For this first iteration, we have only labeled 300 examples, and the model took roughly 35 minutes to train. As you can see on the table on the left, it provides you with a rather good score for the airlines and aircraft, but on the association entity, you only get 11%. This is mainly because we don't have many association to train our algorithm on. So for the next iterations, we would like to reach 90% F1 score, which is a quality score for this algorithm. To train an entity recognition system, you also need a subject matter experts because they need to understand what's the content of the document. So for example, as you can see on the upper right side, this is a screen from EUROCONTROL, but not the EUROCONTROL we know, but instead a quality service company based in Spain. So in this case, we will be matching with keyword detection the word EUROCONTROL, but from the context, you are not able to say that it's a document that is very related to the aviation. On the two other screens, I wanted to show you that on the first one in green, the algorithm managed to correctly tag the aircraft and two airports. However, in the red screen, you can see that it doesn't manage to correctly tag the airport. It tagged it as an aircraft instead. So it's just to show you that this is not perfect and not so easy to train, and we still have to improve in that area. Here is a small video on how to label document for a name entity recognition system. So here we will basically select the entity and then tag individually each FINER in the document, then an airport, and finally an association. Finally, you have this global solution when basically when you provide your raw document, we will extract the content from it and then pass through the content into three different boxes, I would say. The first one is the keyword detection that is useful when you don't have any context around your main keyword. And the second ones will be AI components. The first one is the name entity recognition system, and the second one is the text classifier. These three components give you a global score of, a confidence level for your document being relevant to the aviation or not. And with that, I leave the floor to Patrick.
Yes. So as you can see from this presentation and this early application, we have some main takeaways, which is, well, the security of data is important. The ability to access to those data first, to collect some data, to train them all, because we needed to have some TLP Amber, some TLP Red documents, and by definition, they are not supposed to be shared that easily on a need-to-know basis. So, and to protect the data. So that's clearly one of the difficulty to have access to a relevant set of data, which is quite significant. It's the order of 10,000, even more, 30,000 documents that we needed to make sure that our model was working well. we have overall also a risk of falling into a Western world vision of it. By training a model with certain data set, we are educating it a certain way. And we know that there are some limitations, especially not only because of the languages, but also because of the nature, because of the approach, because of the way to construct information and to share this information. Clearly, AI is helping. So, but sometimes we need one word, 3 letters, the 3 letters of an airline. That's the way to detect it. We can't use the context. So AI alone will not be, I would say, the perfect solution. So the combination of both is needed. Clearly, as I said, the amount of data, is quite an effort. And we had to ask some guys knowing aviation to make sure that those documents were okay, knowing certain languages, and being able to manipulate some documents which are sensitive. So the effort to prepare was quite I say significant, and compared to the effort we will save later, well, you need sometimes such that is paying off. So it's not, I would say, immediate. So think about it when developing it. This is something that we discovered. And finally, what is important, our model, what we like is we are ready to share it so that it can be a bit more robust by being trained on other data set. So here you see the objective is not to share the data set, but to share the model, because the data set will not be shared by definition because those data are confidential and can be shared, but sharing the model could make sense. So that's something that we're ready to consider and for the future. So I will stop here. We will take questions at the end. And now I will hand over to Airbus, to Adeline and Dalel, so that they can show and share with you their experience. So Adeline, Dalel, floor is yours.
Okay, so
Perfect.
So let me introduce the topic for insider protection. So insider protection is a product, as I said during the introduction, so they've been launched 2 years back. It is a product which has been launched in order to fight against a very specific threat, which is the insider threat. So that's why we call it insider protection, because finally it has the will to protect us from some insider attacks and to protect our insider from some kind of attacks as well. So first thing surely is to remind everybody what is an insider threat. So an insider threat, it is simply an attack that come or seems to come from the inside of the company. Whatever if this attack is led by really an internal person which is acting intentionally for to steal data or perform some illegal actions and so on, or if it's unintentional by mistakes, or it could be as well hackers that steal some user credential and use it to enter the network and exfiltrate data, for instance. So that's why we have what we call 3 big classes, let's say, for insider threats. We have the employee with which we call traitor, which is very bad name. This is really people that are part of the company or a partner, but really are performing wrong action, illegitimate action with their account. We have some employee as well or partner that might expose data, but not intentionally, maybe sometimes because they are not well informed, or that simply, for instance, they have been a victim for phishing or this kind of stuff. And of course, one of the big sources, which are, it's typically the case for APT, advanced persistent threats, where hacker find in some way credentials from some user, get some user account, eventually perform some leverage the rights with the account, and slowly crawl through the network and can like this tag data and exfiltrate it. We call it masquerader. The difficulty with this insider threats, really, sorry for this. Oops. The difficulty is that here we have within Airbus something like 300,000 of user account, of Airbus account, mixing employee as well as a partner. And how to find in all those user account, what kind of account could be used for illegitimate account. So what we realized is that traditional methods have some limits to do this, especially because an insider activity don't have a particular signature that could be previously identified and so on. There are patterns of behavior, but not the really factual signature. So the best way in order to find what is abnormal in the middle of all those normal activity, let's say what is unusual, was really for us to explore the machine learning and the user behavioral approach. It gives us the opportunity really to compare the current data with the historical data, so that we can build a view of what is one user account behavior, and then once there is something unusual, the algorithm will be able to spot it, and we will be able to see that there's something wrong happening. In addition, when you look at human behavior, every human has different behavior. So it's really difficult to have tag data for this approach. And with behavioral approach, we can use as well supervised as unsupervised machine learning algorithm. And we use mostly unsupervised machine learning algorithm. So we built a concept which is quite important for us. It is really the heart of the project, which is centered around the usage of behavioral analysis. First of all, we have an insider threat strategy which is at the origin, let's say, of our concept. Within this strategy, we have several what we call anomaly cases. That's really the pattern of what could be something abnormal in terms of cybersecurity. We collect as well feedback from previous incidents we might have on insider threat attacks. And as well, we are able to use to define by ourselves within the team some new possibilities, some new anomaly cases. So once these anomaly cases are defined, we can implement what is finally our detection rule. It is clearly where we develop some algorithm. And we use both individual behavioral analysis, where above here you have an example, meaning you can see here with the two curves that based on the historical data from the account, the algorithm can predict behavior by user. And if there is a deviation compared what is predicted, we can spot it. This is a peak. The red peak shown here. But we can as well use another principle, which is a community behavioral analysis that I will explain in the next slide. Whatever we can have, so several anomaly cases, several techniques to analyze behavior, and we aggregate all those results into one single value, which we call the KTI, the key trust indicator. And this key trust indicator is generated for each user account each day. And what we analyze really and provide most of the value is the analysis of the variation of this KTI that we group all the threat patterns. So what you can see here at the bottom right is a view of a KTI variation based on real value that we collected during the crisis. So here you see a clear drop of the KTI at the moment where the attack has been performed. This KTI variation, it works a bit like if you are familiar with the financial market index. It's like the VIX, the volatility index that can predict crash from financial markets. So it's a bit since principle, the analysis of the KTI variation. So we have a full list of patterns that we can analyze thanks to our algorithm related to data collection, exfiltration, the first access, or privilege escalation, and so on. What I want to show you is an example which is quite simple: access of data outside of normal working hours, something that anybody can understand quite easily. So don't be worried, but it's just to expose this nice formula, what can be the difficulty and the real mathematics behind the scene. Here, what you can view is graphs that reflect what we can do in terms of community behavioral analysis. So this graph is a representation of what the algorithm can do in terms of clustering of user behavior when we speak about abnormal working hours. So the different colors are kind of tagging the type of users that we have. For instance, here in pink, you can see as a user that are partially working in front of the computer. You have the users that we identify as standard working hours. We have the people in green, which are usually working very late at night, and some profile with a very, very, very high activity. And so what we can see here, if you look, for instance, at this individual, this pink point here, this pink dot, we can see that this individual is very far from the rest of its community. And this is something that we qualified as abnormal. So what we are doing is that we are measuring the distance of this individual compared to the rest of this of his community. And with this calculation, we aggregate with the normal behavior of the user. We calculate a score for what we call the UC7. So it's really abnormal working hours. Sorry for the number. It's all code. Well, this represents one of our detection rule, and all those detection rule, as I said, will be aggregated to provide a key trust indicator. So what we are doing, how we are collecting the data, most of our data are coming from security logs, which are in our CM. So for Airbus, it's Splunk. We might as well collect other data sources like HR data sources. We pseudo-anonymize our data because it represents a high number of data each day, as you can see. And we send this selected data into a computing platform, which is on AWS because of scalability, particularly possibility and performance. So we compute all our algorithm in this computing platform, and then we send back our result in the CM so that the expert, this really cybersecurity expert, can have a deep dive of the individual activity with the highest variation in the KTI. So right now I will end on the mic to Dalel, will show you a short demo of the tool. It is exactly what the expert, cybersecurity expert, will see using our application. Dalel, the
Thanks,
floor.
Adeline. Okay. Can you stop sharing, please? Okay. Here we have, it's our first version of the dashboard. The analyst, SOC, or the CERT can connect to this dashboard to see the detected potential suspicious behavior and also start investigating these behaviors. So what we will see on this dashboard is some results computed during October 2020, but the models are trained during the 5 months before October. So here the analyst can, for example, choose analyzing some type of account, for example, if it is internal, external, or affiliate. He can also focus on one or more country. So on this dashboard, we monitor only about 21,000 of accounts. It's about 9% of our target. We can see here the average of the KTI for all users for the last day of October. And here we have an indicator of the KTI variation. So if we have a big value of the KTI variation, that means that we have a big variation on the user behavior. And the KTI the value is between 0 and 100. 0 means that we don't have any confidence on this account, and 100 for full confidence. We have also here a plot about the user distribution. So most of the users monitored here are external. It's about 99%. And here we have the top users sorted by the KTI variation. If we take one user, we can see the KTI variation. For example, for this user, we have like a constant value of the KTI over time. And for this day, we have a peak, a decrease of the KTI values. So we can also see the anomaly case detected on this day. And we can see also, by clicking here, the variation of the KTI. If we choose another users, so here we have the KTI variation. We have also the anomaly detected for this day, and the KTI also, we can change the date to see also the detected anomaly case for other days. And if the analyst, SOC or CERT wants to investigate or to go on deep of on the activity of one user, he can click on the details of this user, for example. And here we have more details about this user, his company, his country, the department. And with on this table, we have the top days where the KTI variation is big. We can see here it's the same. So we have the KTI variation, we have the anomaly score, and if we click here, we can see why we have this score for this anomaly case on these days. For example, for AC7, the objective of this one is to detect any connection outside of the user working hours. So here, for example, with this pink, so it represents the normal behavior of, sorry, the green one, it's the normal behavior of this user. And here we can see that on this day, this user connect at night, that it is abnormal regarding his behavior. We can also choose another one. It's AC search. You have a short description on which we want to detect using this anomaly case. For example, for AC search, the goal is to detect any anomaly regarding to the email sent outside of Airbus. So here we have a different sensor. The sensor for us means the behavior we detect to detect this anomaly case. And we have the description of this sensor. Here the idea is to detect if we send a big number of emails sent outside of Airbus, and we can see that on this day we have a peak regarding the user behavior. And here for the sensors too is to detect any abnormal volume of files sent also outside of Airbus. So that's all for this demo. So thank you for your attention.
Thank you very much, Adeline and Dalel. So while Patrick is taking over, I think this is showing the benefit of AI/ML when you have a lot of data and when you have some complex system to solve. It's not easy to, I would say, not only manually, but I would say via some usual software to address that. So that's where this kind of system definitely show their added value. So Patrick, I hand over to you, please. You have to unmute so that we can.
Thank you, Patrick. Not easy with the interface of Zoom. So thank you. Artificial intelligence applied to malware hunting in ATM systems will be my presentation and demo. So I let you discover some key figures of Thales regarding Thales in ATM domain and cybersecurity. And I would like just to introduce my presentation saying that Thales has a very large portfolio of security products called cyber solutions, and Thales adapts those security products to vertical markets. So in the framework of this webinar, I'm going to focus and to talk about cyber hunting and cyber threat hunting and detection capabilities about and for unknown attacks in an ATM system using, of course, artificial intelligence algorithm and engine. So just to also introduce this presentation, cyber threat hunting is today one of the most complex activities in cybersecurity, and artificial intelligence is, I would say, one necessary companion, and this is what I would like to show today. So let me first talk about our capabilities in detect and response in ATM domain by introducing you this view, which is a business impact analysis view. This view displays impacted business and functional capabilities with regards to detected potential threats, potential attack in an ATM system. And so this view is unique and offers very high added value as almost no cybersecurity skills are necessary to operate it. Indeed, it is business and functional centric. And so the core of this view is represented through the global architecture of your ATM system, and which is configured once at product deployments. And then, as I said, it displays the impact assessments to operators regarding detected threats. So this view allows, of course, to take quick decisions thanks to the impact assessment and to prioritize security, treatment, and incident management. So hence, it offers also first-line response capabilities. So for known attacks, the impact assessment is done automatically and displayed to operators. And for unknown attacks, we prefer to perform hunting, threat hunting activity before assessing the attack, the potential attack with regards to the business, in order to avoid too much false positives. So here on your screen, you can see a red rectangle associated to a server in the center of the architecture. So let's imagine this is a detected cyber attack. Okay, thanks to the hunting we are going to perform together now through the demo. And let's imagine we are this technical analyst, the threat hunter, who will perform cyber threat hunting activity. And also, let me define what is threat hunting, because maybe some of you does not know or are not very familiar with this word. It is an activity to look for a compromise within a system. So now let's go deeper and let's see the scenario for the demo I'm proposing to you. So in front of you, you have a representation. So it is a rough representation, of course, of an ATM system with workstations, servers, network devices, of course. And also I represented some so-called EDR and NDR, which are endpoint detection and resolution. And
Patrick, we are losing you.
Wait, can you hear me, Patrick? Is it okay?
It's okay now. It's
okay. Thank you. So I don't know where it cut. So
endpoint, you are saying what was endpoint and NDR.
Thank you. So EDR and NDR, so endpoint detection response solution and network detection and response solution. So those two components are optional, of course, within the system, but I represented them, because it is quite interesting when we are doing some hunting and investigation, as it gives us more information. So I hope that my technical issues are okay now. So here, the ATM system is represented with its main external interfaces. So sensors network, private networks such as SWIM, for example, and internet public network, such as connection to the ATFM cloud service, for example. So you can see on the right now Cybers Analytics, which regularly receives all machine network devices, software, and also EDRs, NDRs, logs, and alerts. And so Cybers Analytics gathers all those data, and Cybers Analytics has many capabilities, functionalities about detection, investigation, and hunting. So what I didn't say is that Cybers Analytics is our core, I would say, product for such kind of investigation, mixing, I would say, detection and hunting capability, also with artificial intelligence. So for the capability mixing artificial intelligence today, the main data which are used are IP address, domain names, URLs, and files. So now, before starting the demo, I would like to introduce the scenario, the attack scenario. So, because it will not be part of the demo, and so it is introduction. So the so-called kill chain. So let's imagine an attacker, wherever it stands, deploys a malware within the ATM system. It can be also an existing malware spreading itself within the ATM system. So this is what I intended to represent on the private network. So once the malware is deployed, the attacker will need a command and control channel with his malware in order to understand where the malware is inside the system and where or which command he should send to the malware in order to perform the rest of his attack. So I'm not going here to detail the rest of the attack, as there is no need for the demo, okay? Because thanks to machine learning capabilities and the engine of Cybers Analytics, the attack and the command and control channel is detected upstream. So this is what I'm going to show to you during through the demo now. So, can you see my screen? Can you confirm that you see my screen? Yes, thank you. So in front of you, you have the HMI of Cybers Analytics. So it's a bit more technical than the previous one regarding business assessments, or business impact analysis, sorry, but it's not such complex thanks to the features of Cybers Analytics. So let me just introduce you the menus of Cybers Analytics in order to show you the capabilities. So first of all, you can see the three first menus about alerts, threat intelligence, and files analysis represents what I would call the main information sources, of course, in addition to all logs for Cybers Analytics. And then you have the hunting and investigation capabilities with lots of sub-capability, I would say. And we are going to enter and to look at one capability today, which is about command and control hunting, command and control communication channel type hunting, which relies on artificial intelligence. So let me click on it. So you have a new interface now, which has been loaded. So on this dedicated interface, Cybers Analytics shows us that amongst all communications, it detected command and control type channels. And it detected that especially one web domain was contacted. So what also is interesting is that thanks to all gathered data, it is able to evaluate or to give a score to the threats. And for this web domain, it evaluates the threat at almost 90%. So let me just make a little focus here, because this is where artificial intelligence is used. Indeed, thanks to its engine, thanks to all the learning part it did, Cybers Analytics detected in few seconds one threat here in the real system, because that was a test platform. In the real system, it will detect lots of channels or lots of threats, and then giving scores and allowing the threat analysis, the threat hunter, to investigate each threat. And so what is interesting is that it did it in few seconds, where for a single human or even several humans, it would take hours or even days. So the way it works, we choose a semi-supervised approach for this detection capability. And so thanks to, I would say, some hours of learning, the Cybers Analytics is now capable to detect, to differentiate normal traffic to abnormal traffic, and especially command and control type traffic. So now if I go further, let me introduce you the investigation part, because once the AI engine has given a score, once it has revealed the threat, we have now to investigate a bit more in order to qualify the threats. So you have here in front of you a lot of communication session, past communication sessions. And so while I'm investigating, I need to select at least one session to start my investigation. So this is what I'm going to do now. And now you have a new interface, which is the investigation per flow parts. So on this interface, what is interesting is that first, the NDR, because on our test platform we put some NDRs, the NDR did not detect such threats. And then we have some information thanks to all network data we have, and those information give us the IP address within our ATM system, within our ATM domain, at the origin of the communication. So now if I go further and I go to the endpoints, the network data are crossed with endpoint information, and I can now have also the name of the machine, but also the process, the program at the origin of the communication. So this is quite interesting. But I would like to go further, and I would like to know if my system, I would like to know if my system is, how my system is impacted, how the malware spread inside the system. So let me click on the dedicated link, and I will have another interface, and about investigation per process. And so on this interface, what you can see and what I can see with you is that there is in this demo a single machine infected. Okay, I have still the process at the origin of the communication, of the command and control communication. But I have also more information thanks to this interface. I know also the parent process of the malware. And so this is quite interesting because now I can start, I did some investigation and I can start also to elaborate my remediation plan. As you can see on your screen, it is, of course, it is the name of the program, so it's a bit technical, but it is Acrobat Reader here in this demo. So I know that Acrobat Reader launched the malware. And so, of course, it is probably due to the exploitation of a vulnerability. So now I'm able to elaborate or to start the elaboration of a remediation plan, and also to give the information to the SOC, to operators, in order to update the business impact analysis view in order to evaluate and to assess the impact on the business and functional capability. So as a takeaway from this demo, so I would like just to, to come back to my slides saying that, well, I hope that I convinced you, or at least I illustrate to you that artificial intelligence is a very useful capability when we need assistance to threat detection and to also hunting, to threat hunting, thanks to all upstream data consolidation. It requires a few minutes, a single expert to analyze and investigate. Whereas without such capability, it would take hours or even days and probably several experts. So as a sum up, I showed you artificial intelligence and machine learning capabilities for cyber threat detection and hunting. And we are here, of course, at the crossing point of aviation, cybersecurity, and artificial intelligence, of course. So thank you very much. Thank you for your attention. And now, Patrick, I leave you the floor and give you the mic. Thank you.
Many thanks, Patrick. That was really illustrative. And I think that, again, as for Adeline, it shows the benefit of having this kind of applications, having a lot of data and having to understand and correlate a lot of very different information. That's where it's really helpful. So thank you very much for that. Now we'll hand over to Hannes, and Hannes will take a different perspective. We'll try to show us how maybe we can use AI to, I would say, misuse, maybe more than use AI to modify the behavior, and how I would say we can attack, if I may say so, this kind of application. So you can understand that this topic is sensitive. So NS will show you certain things to a certain extent because of the sensitivity of the topic. NS, floor is yours.
Yeah, thank you, Patrick. So as you rightfully said, you have been you had the pleasure now to listen to my fellow panelist colleagues where they presented on artificial intelligence solutions that helps to be more cyber secure. I will be taking a bit of a different posture today. So we'll be talking about obviously artificial intelligence, machine learning, but we'll also hear a bit why machine learning models sometimes screw up and think a punt is a given. And this might some of you now disappoint. We will not talk about these friendly chips today. No, but seriously. So as in the beginning said, we're about demystifying artificial intelligence. So the whole narrative of this presentation will be a very high level. I will not go into detail because we don't have too much time to do that. My objective is to bring you closer to the dark side of malicious of machine learning and artificial intelligence, and also answer partially the question why cybersecurity and privacy are critical to build robust artificial intelligence. We'll start off with showing you which kind of impacts we see on the global security landscape. what kind of new threats are going to be introduced. You will see a bit of fake and deep fake, so how artificial intelligence can be used to manipulate us as humans, but also the other perspective, how we humans can attack artificial intelligence algorithms. Then I'll try to link these two topics, how we can use deepfakes to attack an AI system. And in the end, we'll try to figure out if we can do something, and if yes, what we can do about it. Just a disclaimer on the bottom. Some of these scenarios will be quite a high level, as I said before, but also have a very academic nature, but still, as it is also applicable in the cybersecurity realm, if you can imagine it, you can usually do it. It's just a matter of when and not if. So let me start with the famous quote from Andrew Ng, Stanford professor, and one of the leading experts in artificial intelligence, where he introduced AI as the new electricity. So it's what he wanted to say is, I think that it's not just a technology; it's something that is really transforming everything what we, the whole world we are living in. So it will find its way into many areas that we are experiencing now. So switching to the threat landscape that we see that is introduced by the use of machine learning and artificial intelligence. So it's important to state at the beginning, AI is a dual use nature paradigm technology, which makes it very accessible to a wide range of people. Some of them have good intentions, some of them have bad intentions. This also applies, of course, civil use and also military use. And the introduction of these new capabilities can be used, of course, to launch so-called AI-enabled or AI-aided attacks, but also introduces vulnerabilities at the stakeholders that are deploying this kind of systems, because other people can exploit these vulnerabilities to their advantage. So, what makes AI so transforming or so challenging? It's simple said, it's the scalability, because it can do many things much better than humans. For example, as we heard today, it can very easily go through a lot of data, analyze it, help people make decisions, or even take decisions on its own. It's also the scalability that makes AI so effective, because just imagine an example of creating a spear phishing campaign where all the background tasks, which usually needs to be done by humans, to investigate the background of people, to find out which interests they have, etc., which organizations they work. This all can be done by a machine learning algorithm. Up to even crafting the email and sending out the email with the appropriate payload, because they know which system they have, and etc. So this is something that is reduces dramatically the costs and increases the effectiveness of the system. On the other hand, it has also much wider implications. It has the potential to reshape the geopolitical power landscape, because you need a lot of computing power to really have effective machine learning and AI operating. And some of you might know that we currently are going through a time where we have a shortage in chips or silicon. And those states or those regimes that have access to these chips or are in control of supply of these chips, they will also have the advantage in artificial intelligence capabilities development. Now referring back to what Andrew Ng in his famous quote said, a list of a few industries where we see already the application of machine learning and artificial intelligence enabled systems. Just to mention a few, surveillance security, in the security, which also falls into which you also could understand as the defense area. Surveillance systems, example would be facial recognition and anomaly detection when you, for example, have large-scale surveillance systems over cities. Transportation, the typical area where we are working in, autonomous driving, increasing efficiency of traffic, These are typical applications for these kind of technologies. Medical is already quite known which has high hopes for improving the healthcare system. Finance, real-time stock trading. This is something that is also an exploration, and something that I wanted to highlight to also freshen up this webinar a bit. We assembled a video of 4 clips about a deepfake video to show you what is possible with technology nowadays. It's not difficult, and I hope, we'll just let the video speak by itself, and enjoy. We'll come back later to this. So just have to switch to the sharing. So enjoy.
Yeah, I'll be right there, Steve. Hey, what's up, TikTok? Look, I do a lot of my own stunts, but I also do a lot of industrial cleanup, okay? It's important. So obviously you keep your hands clean, but you need that exfoliating product to really cut through the grime. Okay, just another tip for you talkers, or the TikTok tips. I'm getting too old for that. I don't. Internet.
बधाई हो आप सभी को, क्योंकि अभी अभी नागरिकता संशोधन बिल.
Jai Shri Ram, greetings to all. Friends, I'm here just to ask about the work accounted for. सारिया ने मेरा जय श्री राम. दोस्तों, मैं सिर्फ काम का हिसाब लेने आया हूं.
The men who went to the moon to explore in peace will stay on the moon to rest in peace. These brave men, Neil Armstrong and Edwin Aldrin, know that there is no hope for their recovery.
The men who went to the moon to explore in peace will stay on the moon to rest in peace.
Of course, beyond the many amazing use cases of deepfakes in reviving deceased actors, creating beautiful visual art, redubbing movies, and more, we have to be vigilant about the fact that they can also be used for nefarious purposes. The goal of this video is to let you and the public know that these deepfakes can now be created quickly and inexpensively, and they don't require a trained scientist anymore. If this can be done, it is of utmost importance that we all know about it.
So I'll leave this video now speak for itself. Instead, I want to introduce another deepfake trend that has been investigated by recently in a study by the University of Washington. But first, before I come to what is feasible nowadays, I'd like to take you on a big trip backwards in history. The changing of geography, or the altering of maps, it's a centuries-old practice that has been done by many states, kingdoms, etc. Whoever found use to make it, because it was very obvious that the maps have always been perceived as a source of truth, and they were very powerful for also shaping national identities. This practice was called persuasive cartography or cartographic propaganda. I have a few examples for you how they looked. Here from the 16th century, the Leo Belgicus was one of these eras where maps, where animals were used to shape the outside perception of countries. Another one where it was soon identified that the use of color and also the use of perspective can shape the perception of people. Here, the Communist Contagion from 1946. And also to convey a political message here, The Awakening was published in 1915, which was created as a celebration for the suffrage of the universal right to vote for women. And you see Lady Liberty walking from the west of from the US to the east, basically saying this vote is coming for you, women, for all women out there. But we wouldn't be here in this webinar if we wouldn't talk about what AI can do in this context. The thing is, when we talk about synthetically generated satellite images, this not only is beneficial, but this can create a lot of concerns, especially when you think about disaster recovery, disaster planning, disaster relief, military planning, etc. So you have to rely on accurate satellite imagery to be able to plan what you're doing in the field. And the image you see on the right is, as far as we know, is a real one. This is something published by the Institute of International Security Studies, and it was gained through open source satellite imagery. And the objective was to follow the development of the Iran's ballistic missile the program. So just imagine if this information is inaccurate, it could unwittingly start unwanted and disproportionate diplomatic reactions. Now back to what I mentioned before, the University of Washington made this study on how they could synthetically generate satellite images. You see now at A is basically a base map from an imaging software, and next to it B is the accurate satellite image of the same area. So they used a GAN, a generative adversarial network, we'll come to that in the next slide, to produce synthetic images of, so basically create synthetic satellite images which don't exist in reality. The output was C and D in this picture. C is basically the same, resides on the same base map as does D, but there are different characteristics of different states. Different town cities. So you have a Seattle version and a Beijing version. The problem here is that you can see the streets and the blocks are oriented very similarly. And only in D you see these dark fragments, which can easily be understood by humans, either as low resolution than a deep fake satellite. So this is the problem that you are creating with this. You create very convincing fake images that they're indistinguishable for humans. So attacks on machine learning and AI and adversarial machine learning. So this is where we go to the meat of how we can work against these systems. And so to clarify, adversarial machine learning shall not be confused with generative adversarial networks. So GANs are mainly used for benevolent outcomes. So basically, it comes from game theory, where it's used to train your machine learning model to be more accurate in classifying. So it's a generator and a classifier, and they basically train each other. In contrast, adversarial machine learning has the objective to confuse the machine learning model, and is very often used as malicious intent. There is a few examples of of the users of a GAN. For example, these people that are appearing now on the screen, they do not exist in real life. They are synthetically created. There is a website, it's called thispersondoesnotexist.com, where with each refresh you see a new face. These are non-existing people. And sometimes the algorithm does not a good job. With this picture, for example, you see a fragment on the right side of the kit where there must have been an error in the algorithm. So this is what a GAN is usually done for. So in that case, these images would be fed again to the classifier of a ML machine learning model, and to improve justice accuracy. There are other vulnerabilities of machine learning and AI, which is which try to mess with the classifier on a short-term basis. They're called evasion attacks. This is a classical example of an evasion attack. So researchers found out that you can trick a Tesla autopilot just by sticking a bit on the speed limit sign to make it go 85 instead of 35. And there is also a similar attack, it's called model poisoning. The difference between model poisoning and the normal evasion attack is that the model poisoning has the objective to be persistent. So to make the machine learning system believe the false input is true. Just another example of an evasion attack. I think these are very popular ones, to make the algorithm think that a cat is a dog just by adding some noise to the image. So it's quite common. And exactly to avoid these kind of things, guns are used to train the ML model actually. And there's another thing which is sometimes doesn't get the necessary attention, the desired attention. And we heard already today, there is an application where the model is trained on emails. You can, for example, you have a neural network that is trained with a lot of emails, and the attacker wants to find out what is the content of the email. For example, he wants to find out if a certain social security number is inside the model. And it just makes a brute force attack with queries, and the response with the highest probability factor, there's a high probability that this social security number is in the model. Another example is Google Translate. We all know it does a good job in translating text. This was trying to do Somali translation into English, and the output is quite surprising. And if you put this output into Google, you will find out that the roots of this translation lie somewhere in the Bible. So it gives an indication that the algorithm has been trained also on the Bible. And if you don't think that pigs can fly, may I convince you from the opposite here. So, and now trying to link these things together, deep faking and attacking an AI system. I took one of our projects we have in EDA, it's called SafeTerm. It has the objective to identify flight termination areas in case of multiple system failure for an unmanned aircraft system. Please understand that this is a very abstract version, and this is a hypothetical scenario, which is already mitigated in the real model. So don't try. So the thing is, you have this ML AI algorithm here in the yellow box in the flight termination area decision-making column, which will decide what is the best place to land this unmanned aircraft in case of failure. This algorithm is fed by real-time the sensors from outside the US, like camera sensors, but also from internal sensors to always be aware about attitude, about system state, etc. Everything goes through a software layer, and based on that, the decision is done by the machine learning algorithm. And now imagine that this machine learning algorithm is trained by adversarial machine learning, and just has a different or a false perception of reality. This could lead to potentially catastrophic outcomes. And this is actually the real heat map of what is used for the SafeTerm, where it classifies different landing areas. So, and what can we do to work to counter these kind of attacks? So can we do anything? The good answer is yes. But all these recommendations or all these things are very generic things that you should anyway consider when you design IT systems, but they have a different focus. And if defenses should be effective, then you need accurate test data. So you have to know where that data comes from. Does it come from reliable sources? Is it appropriately tagged, etc., etc. Also, you should make sure that it can resist adversarial examples. Here the application of general adversarial networks comes into play. So train it with adversarial examples as good as possible to make it as robust as possible for any attacks on the classifier. Do adversarial training, like I said before, include adversarial examples in the training set. There are different approaches here. Heuristic defense, where the defenses can be quite broad, so they can be quite effective, but there is absolutely no guarantee on the performance of the defense. And then there is the certified defense, which I could imagine could be something interesting for everything that is safety relevant, where in a specific scope, in a very narrow scope, you have a guarantee that defenses are working. But in the end, we have a cat and mouse game like we have in cybersecurity. You cannot detect what you don't know. Input transformation is just a different, easily said, it's a very different way of adversarial training. And important, and this is why I mentioned the example before with model stealing. Always consider security and privacy, because this is something that you don't want to have sensitive information leaked from your model through brute force attacks. Here are a few questions that you should ask yourself when designing your model. They basically resemble what I said here. I think because time is pressing, I will just go on. So concluding is, be really aware when you design a system, what is your accepted risk before you regret it. And if you don't do it appropriately, your autonomous vehicle or whatever will somehow hit the wall or the bridge. I thought this image is quite speaking for itself. And always consider that while we humans are hooked, the machines keep on learning. Thank you very much.
Thank you, Ernest. Thank you very much for showing us we can, I would say, impact the behavior. And I think you have kind of illustrated, the domains and slightly in aviation in a way that we suggest. Of course, we can't go too deep because you can imagine that this is sensitive, but I think the message was clear. The message was very well received. Many thanks for that. So now it's time for questions. And I see that we have some questions in the Q&A. So I will take some of them and I will ask the panelists to ensure short, please, so that we can address as many as possible. So there is a burning one, which is clearly worrying a lot of the participants for you, Adeline and Delal, which is, well, you are looking at, you see data which can be perceived as monitoring the behavior of individuals. So how those, from a legal point of view, from a trade union point of view, from a GDPR point of view, how all that negotiated and accepted? Please let us know.
Yes, this is a very, very big question for us. And you need to know that we considered GDPR at the very beginning of this product conception. And we, while developing all the concept and the tool, we have been working very strongly together with our organization in charge of data privacy. And let's say those constraints are included by design in the tool. I don't know if you paid attention, but on one slide, I just mentioned that all the data are pseudo-anonymized. It is not a full anonymization because in case there is something wrong happening, we absolutely need to reconnect with the logging of the user account at the source of the problem. However, all the data that come into the computing platform are anonymized and no human is looking at the data. It's only the algorithms that are handling it. And the result is an aggregation of all the data. So finally, the number by itself don't speak that much. What we are doing is aggregating, we're generating a list of things that look suspicious, and it's up really to the people which have the power, the legal habilitation to investigate, that will investigate if really there is something popping up.
Yeah, thank you for that. And I remind that in the GDPR, there's a recital 49, which is meant to allow cybersecurity incident investigation to be conducted. So that's part of the GDPR. GDPR is meant to allow these kind of activities. A question for Julien, because you are one of the young chap, and I would like to know a bit, was it easy to jump into industry when after your master? Was the master degree well suited to prepare you for the reality of industry? In fact, well, do you need a kind of, what kind of education? Was it difficult to enter into this topic?
First of all, I would say that you definitely don't need a PhD in data science to enter in this domain. But still, when you enter into this area, you should be prepared to learn a lot. As this is a fast-moving environment, you should always be prepared to learn and constantly adapt to new technologies that are arising on the market. So that's one point. Another one would be that I would say that a good data scientist should be someone that is curious, and also someone that has good analytical skills on the whole. But to answer more deeply your question, I would say the university teach me how to be curious, where to search for good sources, how to criticize what I read, and how to adapt.
Okay, thank you very much. A question for Hannes. What would be your recommendation to secure the use of AI ML?
So the recommendations are quite they're usually quite generic, and I would like to. But it's a complex question, but it's not simple to answer. So the thing is, I think that there is a lot to do on the governmental policy level, so that I think there is governments need to provide a framework that is not only that not only supports the development of AI and of more robust AI, of course, but also should do it in a way that it doesn't hamper innovation. This is something that I hear quite often when I talk to other people, that sometimes they say, yeah, regulation is good, but it's just kind of countering innovation. But we have to find the balance in this. I think what is very important to put the policymakers together with the engineers and the researchers to know that both parties or all the parties involved know their interests, and the information flows from both sides, and both know the effect of what I said, that this dual use nature has, which that it can be used for good and for bad purposes, and this kind of information just needs to be present in all the people that create these rules and regulations, and not just trying to cover everything in regulation, because this will not be possible. You cannot, because it's not just a technology, as I said before. It's something much more than technology. It's something that has much more impact. And to bring it a bit more probably to the aviation context is what is important is to identify a way how to make it more trustworthy, the AI, and to make it explainable. I think this is also what I see when I'm in the standardization activities. This is one of the key things that people try to figure out, how to make it explainable, because you have to. It's a safety relevant system, and you have to rely you have to be able to predict what the system is doing in every circumstance. So this would be some very generic recommendations how to make it better.
Okay, thank you, Hannes. Question for Dalel. We have some guys asking whether the KTI has been proven reliable so far. So what is your feedback now?
For the moment, we are under development. So, for example, for the demo, we included only 5 anomaly cases, and we need to include more anomaly cases to see if the KTI is enough or not. But for us, so the KTI will be used to detect, for example, any suspicious behavior. It can be, for example, a big variation or also a regular pattern over time. So this can be used to detect, for example, unknown attacks, but also we developed some known scenario of insider threats, and we will also use our anomaly case to try this known scenario. So we don't have only the KTI, we have also the scenario. And for the moment, so we will be on production in September, and we will work with the SOC to validate the KTI concept. And today we are also on, so we try to develop some statistical approach to validate the unsupervised model and the KTA, and we try to collect some cybersecurity data from our past incident in Airbus to validate the concept of the KTA, but it's under development further.
Okay, thank you very much, Dalal. And a question for you, Patrick. What were the good and bad surprises that you faced when developing this application?
Well, I would say that as a good surprise, well, the developments made data scientists, and so I'm talking about cyber analytics and the capability I showed to you. So it makes data scientists and the cyber expert, cyber analysts working together and collaborating. So it was quite a good surprise to make them working together with lots of, I would say, very good results, which was quite interesting for us, and so that's why we continue this collaboration also strongly. Also, because we decided to have a semi-supervised active learning approach, we also have to work with lots of end users, and we involved lots of end users for the learning parts, and so that was also quite interesting to do this. As a bad surprise, and the drawback of the semi-supervised and active learning approach is that it is, I would say that as it gathers some feedbacks from users, from operators, in order to enhance the detection capability, to enhance the learning parts. I would say that it adds complexity during development and integration, and also we have to develop specific user interfaces. So that was much more complex than expected. So during the development, but we faced these parts, but it was much complex than expected. And also, well, I would say that for the capability I showed to you today, we did some training cycles, of course, for the machine, but it will require maybe further training for very specific system. So this is probably also the drawback of our technology or of our approach. Thank you.
Okay, thank you very much. Yeah, so it's time to wrap up. So in fact, for me, the main key takeaways is that clearly we need to work all together on this topic, and that's something that is emerging. We see the benefit, but we see that, as you have mentioned, all of you, access to data is important. So we need to share that, either the data or the model, so that we can improve clearly. AI is helping. It's not the silver bullet, but it's helping, especially when you have systems which are quite complex with a lot of data. So that's where we can see definitely a future. Hannes has clearly identified that we need to think about how to protect it, because somehow it can be subject to cyber attack and to misbehavior. So we are at the beginning of the journey, and I think that was the purpose of this series of webinars. So to open the eyes, to understand that yes, it's ongoing. It's not dreams. It's not ideas of some guys. No, it's there. We are using it, and it's providing some benefit. But there is a a journey, and we need to invent a future application. So I want to thank you very much, all of you. So Adeline, Dalel, Patrick, Julien, Hannes, for joining us. And I hope that all the participants have enjoyed it. Again, it will be recorded, so those who have not seen it, you can mention that to your colleagues who missed this event. Too bad for them, but they have a second chance. And the next one, the next panel will be on the 30th of June at 1500, moderated by IFATCA and IFATCA, so Staff Association of Controllers and ATSEP. And the topic will be AI training and change management for aviation. So I welcome you to register to attend the next one. Again, thank you very much. It was a pleasure, not only, I would say, delivering this session today, but also preparing it. We had a lot of interaction. I thank you very much for your time, for your availability, and for your eagerness to share and to show how AI can be used in cyber and how cyber can kind of screw it up. Thank you very much. Have a good rest of the morning, afternoon, or late evening, wherever you are in the world. And see you at the next Fly webinar. Thank you very much. Bye-bye.